Good day, class. Welcome once again to another session of differential equation. Now we are on the topic of linear differential equation of order n, meaning we are still on the higher order. We are already on the higher order differential equation. Then last time we discussed with the case number 1, which is the distinct roots. So now we'll be discussing about the auxiliary equation with repeated roots. Meaning, ang iyang mga roots, gabalik-balik. Okay, if you could see here, 1, negative 1, negative 1, negative 1, 2, and 2. That is the repeated roots. So, gabalik-balik ang roots. So, in repeated roots, you have a general equation looking like this. This is repetition. So, magkapila na siya. Okay? So, your y will be equal to x raised to the power of k. So, k will be 0 to so on, depending kung kapila siya ang repetition. But it will always start with 1, 2, 3, and so on. Then, your b here is your roots. Okay? Kanyari, ang root nimo is 1, negative 1 like this. So, negative 1 times x. Okay? By the way, use wala lang gibutan si arbitrary constant here because it is like in the repeated sa distinct roots na naman yun na expected. A constant times this one. Okay? So, here the roots, for example, so general solution, for example, the roots will be equal to b, for example. So, b could be 1, negative 2, marani siya, or negative 1, 2. So, example, for example, in this is your slope is b. So, b, b, and b. So, therefore, there are 4 roots having the same value, which is b. Well, we don't know, maybe it's negative 1, negative 2, negative 3. Basta the same sila. So, the general solution of that given roots is this one. So, again, you have y. Then, count how many roots you have. So, you have 1, 2, 3, 4. So, therefore, you will have 4 arbitrary constants. So, C sub 1, C sub 2, C sub 3, plus, and so on naman nako. For a reason that you could have more. So, but if you have 4 roots, then you have 4 arbitrary constants. Now, the first arbitrary constant will start at x0. So, it will start with x equals to 0. So, here, it will start at x equals to 0. So, x is equals to 0. E times e raised to the power of the root times x. So, the root is b. So, bx. Then, a second arbitrary constant for the second root times mo mag-add 1 man ang ato ang x. So, 1. Then, mura na siya. X raised to the power 0 is 1. 1, x, x squared, x cubed, x raised to the power 4. Yan na siya. Okay? So, let's try an example. Okay? So, not yet differential equation to general solution. So, let's try. So, for example, you are just given with this roots 1, negative 1, negative 1, negative 1, 2, and 2. If you could see here, how many roots do we have? 1, 2, 3, 4, 5, 6. So you are expected to have 6 arbitrary constant. Next, look at the first repeated roots. The first repeated roots is all negative 1, which has 3 repeated roots, diba? So, if you could see here, this one is the second arbitrary constant or the second part. So, you will start at x0, that is 1, so wala siya. So, the next of that will be x, the next of that will be x squared. Okay? So, let's try. So, since this one is not the same with this 2 repeated roots, so this is distinct of that 5 of them, so you will always start in the rule sa case number 1. So, case number 1 is C sub 1. So, since this is the first, that is C sub 1. Kung ikaduha na siya, C sub 2. So, pwede rin na siya. So, since this is the first, you have c sub 1 e raised to the power of 1 times x, that is x only, plus. Now, the next 3 is repeated roots. Since that is repeated roots, you will have x, okay? You will have x multiplied to your arbitrary constant in your exponential. But if that is not repeated, if that is distinct, then you don't have variable x multiplied to arbitrary constant and to your exponential. So, mahitabo lang ng multiplying of x if that is repeated roots. So, c sub 2, so because this is the second root, c sub 2, e raised to the power, so c sub 2, so mara siya ganyan. Let me look for, okay, let's try, okay. So, from here, diba? Let me copy, 1, then tulo, and negative. Okay. So, let's try. So, okay. So, our example, so first example na to is na siya root na 1, negative 1, negative 1, negative 1, 2, and 2. Let me check. Okay? So, okay, 2 to negative 1. So, from here, since we know that we have this 6 arbitrary, 6 roots, we have 6 roots, no? That's not roots, 6, that is 6 roots. So, we have 6 roots. So, therefore, your y will have 6 arbitrary constant. So, let's start with the first one. The first one is distinct to the other roots. So, this is not the same with negative 1 or positive 2. So, c sub 1, since that is distinct, we don't have to multiply it by x. So, dito ra, arbitrary constant times exponential, then our root. The root is 1 times x plus, okay, plus c sub 2, since that is second, multiply by x, because negative 1, negative 1, negative 1 is a repeated root. So multiply by x. The first root, the first of the repeated roots will be 0. Then times exponential. Then the root, negative 1 times x. Then the third one, c sub 3, x raised to the power of 1, because this is still repeated. E raised to the power of, still, what is the root? Negative 1 times x, plus the third one. So, c sub 4, because 1, 2, 3, 4. That's the fourth one. So, times x raised to the power of 2. So, ikaduha naman siya. Ikatulo siya. So, from 0, 1, 2. So, times exponential, root is negative 1 times x, plus this one is another repeated roots. Therefore, since this is different from the first repeated roots, you will start back to this. So, this is the fifth arbitrary or the fifth root. So, since that is the first of another repeated roots, so you will start with 0 again. So, then multiplied by e, then what is the root? That is 2 times x, plus next one, so 6 na root, so 6 arbitrary constant times x, then you will have 1, and then so the sixth root, that is c sub 6 or arbitrary constant 6 times x, since this is the first root, so 0, first of the another repeated root, then this is the second, so raise it by 1 higher, then multiplied by e times, what is the root? That is 2. 2 times x. So therefore, when you simplify this one, you have c sub 1, e raised to the power 1 times x, that is x, plus c sub 1, x raised to the power of 0 is 1. 1 times c sub 2, that is c sub 2 times e raised to the power negative x plus c sub 3 x e raised to the power of negative x plus c sub 4 x squared e raised to the power of negative x plus c sub 5. Since this is another new repeated root, so x raised to the power of 0, that is 1, times e raised to the power of 2, 2x plus c sub 6 x e 2x. So this is our general solution. So this is our general solution for repeated roots. Sa atong example. Let us look at our example. So we have, if you look at here, let me make it more clearer. Okay. This one. Okay. So y c sub 1. Okay. Y c sub 1 e to the power of x, c sub 2 negative e raised to the negative x, c sub 3, c sub 4, x squared raised to the power of negative e raised to the power of negative x, c sub 5, e raised to 2x, and x. So we actually have the same result. Okay. So to elaborate more for your for case number 2, which is the repeated roots. So the same as 1, you will know that the given equation is a repeated roots by doing this one. So if we try, so the given equation, so wala man tayo given equation na ano. So if ang gihatag ninyo is a given equation, so kini wala man ni gihatag ni given equation. So kung ang gihatag na given equation, so differential equation, ma-form nimo ma-equal siya sa 0 ang b, ang a, ug c. Then that is a repeated roots, di ba? Sa repeated roots, kung nang magkinumdum mo sa inyong completing square, we use this negative b over 2a. B is not the root na ha. Ano ni siya katong ABC sa atong equation. So kanang ax squared plus bx plus c nga equals 0. So mo na siya. So that is a linear equation. So to simplify the notation, let r or the root be equal to negative b over 2a. Then we have one solution. Y is equals to e raised to the power rx. Katong gibuhat nato kini. So with 2ar plus b. Okay? So since multiplication of erx by a constant fails to produce the second linearly independent solution, suppose we try multiplying by function instead. So the simplest such function would be u of x is equals to x. So let's see if y over 2, y2 is equals to x erx is also a solution. So here we, in the fourth theorem, so katong case number 1, 1, 2, 3. So in the case 2, we have theorem 4. So if r is the only real roots, okay, is only real roots to the auxiliary equation, so meaning usa ra yung root niya, so then you have this general solution. Katong gibuhat nato. Okay? So money equation, for example, maning gihatag na equation, so the b negative of the constant here na b, money equation, b over 2 times your a. Okay? And that will be your root. So another example. Okay. So ganiha, root ra dayon ang gihatag, tapos nag-uuha ta sa general solution. What if ang gihatag is ang